Organic chemistry. It is a special branch of chemistry which deals with the properties of compounds that were formed by carbon. In earlier days, scientists, particularly the Berzelius, classified the chemical compounds into organic compounds and inorganic compounds, basing on the source from which they are obtained. In those days, most of the compounds which now we are claiming as organic compounds are synthesized or isolated from living organisms. For a long time, it was the opinion of the scientists that these compounds can only be isolated from living organisms and they cannot be synthesized in the laboratory by normal methods of preparation of chemical compounds. That's why they named these compounds as organic compounds, and the chemistry that deals with these compounds are said to be organic chemistry. It was the feeling of all the scientists till Wohler prepared a compound known as urea from an inorganic material, ammonium cyanide. Later on, so many compounds are synthesized in the laboratory just like other inorganic compounds, but the same word that was given earlier stands still just for the convenience sake to study these compounds. Now, what is the importance and what is the speciality of the compounds of carbon? Why they have so much importance? Why we have to study these compounds separately? There are several reasons for this. Because the properties of these organic compounds, that is the carbon, hydrogen and oxygen mainly, the constituents of these compounds, and some other elements may also there. There are a variety of compounds that are present here in this universe. In our daily life, the life is linked with these organic compounds. Now, every day, a new compound is going to be invented in this category of compounds. So, now let us observe why the compounds of carbon has so special characters than the rest of the compounds that was formed by other elements, because we have 92 naturally occurring elements. All these 92 elements are forming several compounds, but we are studying the compounds of carbon separately as a separate branch. The main reason for this is the unique properties that was possessed by carbon atom, and which other elements cannot exhibit this type of properties. So, let us first see the unique properties of carbon that leads to the formation of such variety of compounds. The important compound, the important properties of carbon that lead to form these compounds is, number one, is catenation. Number two, allotropic. Number three, isomerism. Number four, diversity. in the hybridization. These are the main reasons for carbon having these special characters. Now let us discuss one by one. Catenation. Catenation is property of an element that can be linked or formed covalent bonds with atoms belonging to the same element to form a long chains or cyclic compounds. This phenomena is said to be catenation. Generally, the atom of an element can combine with one or two atoms only. For example, if you take oxygen, one oxygen can form bond with other oxygen atom. Suppose if it is in ozone, three oxygen atoms can form bonds with two other oxygen atoms. That means three oxygen atoms can form a cyclic compound. Or if you take sulfur, 8 sulfur atoms can link to form a compound. 1, 2, 3, 4, 5, 6, 7, 8. This is the maximum number. The maximum catenation character that was exhibited other than carbon is sulfur. And this also is limited just to 8 elements only, not more than that. All the remaining elements, just 2 atoms, can form a molecule. Self-linking or forming covalent bonds with atoms belonging to the same element is said to be catenation. If you observe carbon, some thousands of carbon atoms can form strong covalent bonds to form a long chains. That's why we are having a huge biomolecules like proteins, which consisting of a long carbon chains. Some thousands of carbon atoms are linked together as a large chains. Such unique character is not observed in any other element other than carbon. This is the reason why carbon is forming so many varieties of compounds. That's why we are studying the compounds of carbon as a special branch in the name of organic chemistry. Of course, this name is not suitable for nowadays, because from so many inorganic materials we are getting carbon or these organic compounds. Organic means organism. In ancient days, that they felt that a vital particle that was linked with a life is root cause for the preparation of these compounds. But nowadays it is not necessary to synthesize or to prepare an organic compound. There is no need for us to depend on these organic things. But still that name was continuing, just to avoid the confusion. But it is not, nowadays that name was not suitable for all these compounds. Of course, even now also, the main source of organic compounds are the fossil fuels and the living organisms only. Of course, even the fossil fuels, that means coal, coke and petroleum, all these things, we believe that they are obtained from the plants and animals. So whatever it may be, now the term name may not be important for us. Now let us study the unique characters of these compounds. So now we have just studied about the catenation property. Catenation means forming covalent bonds with atoms of same element to form a long chains or branched chains, a huge molecules with the atoms of same element is said to be catenation. This is a unique character that was exhibited by the compounds of carbon. Then the second property, allotropy. This allotropy is the fundamental characters of all nonmetals. Almost all nonmetals can exist in different allotropic forms. But their number of allotropes that was formed by an element is limited to 2 to 3 to 4. For example, if in the case of sulfur, you have nearly 6 allotropic forms in the sulfur. In phosphorus, we have 4 allotropic forms. In oxygen, we have 2 allotropic forms. One is oxygen and other one is ozone. And in nitrogen also, we have 2 allotropic forms, alpha nitrogen and beta nitrogen. Though they are exhibiting different allotropes, the properties of those allotropes are almost similar, are nearer to each other. Allotropy means the existence of an element in 2 or more physical states is said to be allotropy. The existence of an element in 2 or more allotropic forms is said to be 2 or more physical states is said to be allotropy. This is the fundamental property of nonmetals. Though it is the fundamental property of nonmetals, this property was restricted only for 2 to 4 allotropic forms in the rest of the elements. But in carbon, we have nearly 16 to 20 allotropic forms so far identified from carbon. And these allotropic forms can be classified into 2 types. One is crystalline allotropic forms and other one is amorphous allotropic forms. What are crystalline allotropics and what are amorphous allotropics? In a solid, whatever the solids it may be, not only these compounds, we have matter is exist in 3 states, we know, gases, liquids and solids. In solids, they are made up of small building blocks called as atoms. In these solids, the atoms present in it are systematically arranged in a specific pattern. Such solids are said to be crystalline solids. That means in any crystal, if you take a small portion, that portion itself explains you the structure of whole the bulk of that crystal. That means it will have the same pattern of arrangement throughout its bulk. So if atoms are arranged in a systematic manner, in a systematic procedure, with a specific systematic arrangement, such solids are said to be crystalline solids. If in solids, if such pattern is not observed, if the atoms are randomly arranged to form a solid crystal, such solids are said to be amorphous solids. Now the allotropes of carbon can be divided into 2 types. One is crystalline solids and other one is allotropic solids. The examples for allotropic solids: coal, coke, charcoal, sugar charcoal, wooden charcoal, bowl charcoal, lamp black, gas carbon. Nearly 16 varieties of amorphous allotropes are there in carbon. In the category of crystalline allotropes, we have mainly 3 types of allotropes so far identified. The important ones are: one is diamond, second one is graphite, third one is C60. And recently we have discovered nanotubes and graphene. Of course, these two are related with this graphite. So, these are the important crystalline allotropes that were found, and particularly these three are recently discovered allotropes. Let us discuss regarding these allotropes in the next class. Now, let us go through the third unique property of these elements of carbon, that is isomerism. Isomerism, iso means same. So, isomerism means the phenomena of forming different compounds with different properties, but having same molecular formula is said to be isomerism. This is the most unique character that can be exhibited by these organic compounds, isomerism. For example, if we take H2SO4, if I give you the formula H2SO4, without any doubt you will claim it as sulfuric acid, because hydrogen, sulfur and oxygen, when they combine in 2:1:4 ratio, except sulfuric acid, there is no possibility to form a second compound with the same formula. You take any inorganic compound, not only H2SO4, take HNO3, take HCl, take any other salts, CaSO4, or CaCl2, or CaNO3 twice, any inorganic compound if you take, other than that particular name, other than that particular characters, no second compound is possible with the same formula. But in the case of organic compounds, with the same formula, number of compounds with the different properties are possible to exist. This phenomena is said to be isomerism, which is exhibited exclusively by these carbon compounds. That's why we are finding so many varieties of compounds in organic chemistry. For example, if you take C6H12O6, if I ask you what is the name of this compound, you cannot claim, because the well-known glucose and fructose, both of them are having same formula. If I give you any formula for organic compound, it is not possible to identify the organic compound with its name, that's with its molecular formula. For that we require a structural formula. The structure is more important. If I give you the structure, then only you can identify the compound and you can name the compound. So, this is another important character of these organic compounds. So, the first reason why the compounds of carbon are studying separately as a special branch, first one is catenation. Catenation is a unique character of carbon. To link with the atoms of same carbon to form long chains and branches of chains to form a huge molecule is said to be catenation. Self-linking with same atoms belonging to same element, atoms of same element. Then second characteristic property is this allotropy. Of course, allotropic may be exhibited by other elements also, but this number of allotropes was not observed in any other element. All non-metals have this character, but the number of allotropic forms and the diversion in the properties is to some extent only. But here, a large number of nearly 20 allotropic forms are there, and we cannot compare one allotrope with the other allotrope. The precious stones, which we call it as the diamonds, they are made up of this carbon, only exclusively of carbon. And the black mass, graphite, and the coal, all are made up of same carbon. See what is the difference in the appearance of these two elements. So the important allotropic forms of carbon, first they can be divided into two types: crystalline allotropes and amorphous allotropes. In amorphous allotropes, nearly 16 varieties of allotropes are there in amorphous category: coal, coke, lamp black, wooden charcoal, bone charcoal, sugar charcoal, lamp black, etc. And in crystalline allotropic forms, the important ones are diamond, graphite, fullerenes, then nanotubes and graphene. So these are the important allotropic forms of carbon. Then the third character is isomerism. Isomerism means existence of same element. Existence of same element in different physical states, or the phenomena of formation of different substances with different properties by a same element is said to be allotropy. Allotropy is due to the difference in the arrangements of atoms in a molecule. Then third character is isomerism. Isomerism means the phenomena of forming different compounds with different properties with the same molecular formula is said to be isomerism. We studied this isomerism in detail in the later classes. That means the present class only. In the next class or 2 classes we are going to discuss this also in detail, isomerism. That means with same molecular formula we have varieties of compounds with uncomparable properties. That's we call it as isomerism. This is a unique property that was exhibited by these carbon compounds. Then other thing is diversity in the hybridization. We know this is a special theory that was proposed to explain the structure of covalent compounds. All these carbon compounds are covalent compounds. So to explain the structure, it is necessary to study the hybridization. So carbon can exhibit compounds in 3 types of hybridizations: sp3 hybridization, sp2 hybridization, and sp hybridization. Other elements can also form compounds with different hybridizations. But here, carbon forms a variety of compounds with these 3 hybridizations. Not only that, a compound with one hybridization can easily be converted into a compound with some other hybridization. That means a compound of sp3 hybrid compound can easily be converted into another compound with another different properties having another hybridization. That means interconversion of one hybridization to other hybridization is very easy in carbon compounds. That's why they are able to form a varieties of compounds. Moreover, in the same compound, if 3 or more carbon atoms are there, then one carbon will have all the 3 hybridization may found in same molecule. These are the reasons to form millions of compounds by carbon, and their properties are also different when compared to the other properties of the compounds of formed by other elements. That's why these compounds are studied separately as a special branch in the name of organic chemistry.